devices. The recording is meanwhile in progress, and he's talking about or is sharing his experiences with Apkinson. So Juan Camilo, please go ahead.
Yeah, thank you, Gwen, for the nice introduction, and good morning, everyone. It's really good to be back in a TAPAS event. Yeah, I am one of the ESRs of the project from the FAU in Erlangen, Nuremberg, and the University of Antioquia. And today I'm going to talk about our experience developing Apkinson, the Android application, which was developed to assess the speech and movement in patients with Parkinson's disease. Now, I'll start with a brief introduction. As you may know, Parkinson's disease is the second most prevalent neurological disorder in the world. Patients develop several and different motor impairments in the speech and in the movement of different limbs within the body. In addition, according to some studies, Parkinson's disease exhibits many of the characteristics of a pandemic, similar to what we are seeing today with COVID. The disease is experiencing an exponential growth, and particularly no one is immune to the conditions. Particularly the increasing longevity and industrialization, it seems to fuel the presence of the disease within the world. The motivation behind the developing of Apkinson and in general about this study is that the identification of different biomarkers for early diagnosis, disease severity, and response to therapy is a primary research goal today, with the aim to slowing down the impact of the disease, especially when the patients are already diagnosed. The continuous monitoring of the state of the patients, either the global neurological state or the disaster severity in the speech, will help in slow down the impact of the disease. So we saw a need for a system to track the disease progression continuously through time, like every day. And how to do that? Principally with a mobile application that combines the speech analysis and movement analysis, with the aim to benefit patients, caregiver, and clinicians. The main aim of the app is to collect data from patient speech data and movement data. The app made some processing about the signals that are collected and gave feedback to the patient about their current health state, either their neurological state or their disaster severity in speech. But the global vision that we have about the future of digital medicine for monitoring Parkinson's disease patients, it's on the one side to have the patients collect data from patients, either speech, gait, and movement data, either using smartphones and a smartwatch. And on the other side, we have the neurologists, the phoniatricians, and general the clinical experts to analyze and to get insights about the data collected from the patients, and everything is going to be connected with the electronic health records of the patients and combined with pattern recognition and signal processing strategies to get the most useful information according to the disease progression. No, the rest of the talk, I'm going to talk about Apkinson in general, what are the core components of Apkinson's, the speech and movement analysis that are within the app, some results obtained. Finally, we'll talk about the outlook and where to go from here in order to keep growing up the analysis of patients with different neurological disorders using mobile devices. Now, Apkinson. Apkinson is an open source Android application. The source code is available for the research community and in general for everyone, which can take a look. The main aim of the app was to continuously track the progress of Parkinson's disease patients using speech and movements. We have like a profile It was a working project between two universities, the University of Erlangen in Germany and the University of Antioquia in Colombia. The app was developed by 8 graduate students from each university, which we sit together within 2 workshops to develop the core components of the app. So I like to take the opportunity to acknowledge to all of the contributors to the app. Yeah. What is the history of Apkinson? Apkinson starts as a master thesis at the University of Erlangen in 2016. Then, within the 2 workshops that I already mentioned, 2 workshops founded by the Ministry of Science in Colombia and the Ministry of Education and Research in Germany. We had 2 workshops, one in 2018 and another one in 2019. The first one was held in Medellin, Colombia, where we start to build the app, and the second one in Germany, where we just finish the app or the current version of the app. Now, what are the core components and the main components of the app? We have a user profile of the patients that where they can track the daily progress of their exercises. They can access in a very easy way to their different exercises that they have to perform like every day, and they have a reward system in order to track their progress, in order to see their results, in order to check their medication intake, among other different features. Yeah, there is a large list of available exercises that the patients can perform at home. There is at least 32 exercises regarding speech, movements, and finger tapping. Yeah. We have Apkinson incorporates a daily schedule system with an integrated exercise manager to select a group of 5 or 6 different exercises that the patient have to perform like every day, combining different speech and movement. For instance, for today's exercises, the patient have to do some diadochokinetic exercises like the rapid repetition of ta 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 ta, ka 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 ka, a sustained phonation of the vowel u, gait exercises within at home, and a sliding exercises using finger tapping. Every exercises, speech and movement exercise is comes with a spoken instruction, so the patients can play a video to explain the purpose of the exercises. Yeah, and the patient can start and understand what they have to do, and they can start the exercises like every day. And the app incorporates as well 3 finger tapping exercises that walking and movement exercises to track the progression of the disease in terms of the movement of the upper and lower limbs. And finally, after the patients finish the 5 or 6 exercises each day, we gave a positive feedback to the patient in order to motivate them to keep doing like every day. I think the most important part of the app is to keep motivating the patient to do this therapy, to do the exercises every day in order to slow down the impact of the disease. We gave positive message of the page to the patients about their score, and we compared the results in each component in different dimension, speech, finger tapping, and global movement. And we show their results and compare them with a group of healthy controls. Now, Apkinson inside incorporates some methods and some algorithms for speech and movement analysis. Now, regarding speech, Apkinson records a total of 21 speech exercises, including utterance of the kinetic exercises like the rapid repetition of syllables like pataka, 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 phonations of sustained vowels like I, U, some red sentences, and the description of images. For those 21 exercises, we performed an analysis based on 4 different dimensions of speech. The first one is the stability, which aims to model the stability of the vocal fold vibration when uttering sustained vowels, how the pitch and the loudness are stable when patients pronounce sustained vowel phonations. We have a prosody analysis based on intonation and speech rate, which are analyzed in the red sentences. We have pronunciation analysis based on the use of phonological features to track how the different plosive sounds in the kinetic tasks are performed. And Apkinson incorporates within a server a speech recognition system to track the intelligibility of the patients when they pronounce different red sentences. Now, regarding movement analysis, there is a set as well of 14 different exercises that are tracked using the inertial sensor of the smartphone, particularly the accelerometer and gyroscopes that are embedded within the smartphone. And we as well evaluate like 5 different dimensions of movement, like regularity, how regular and stable are the different movements when the patient move their arms, track the presence of freezing of gait in the walking exercises. We evaluate as well the stability of the movement with the patient like just stand with their phones in their hands, or to evaluate the presence of resting tremor. We have as well hand tremor evaluated, and gait kinematics, like what is the average length of the steps, the velocity of the steps when they walk, among other different exercises, among other analyses that are present within the app. And finally, we include 3 exercises to evaluate fine motor skills based on finger tapping. 2 of them are based on touching the ladybug with the thumbs as fast as possible. And the third one aims to move this sliding bar to the target position as fast as possible. These data are captured using the touch sensor of the smartphone. Now, with all this analysis, we show the patient feedback about their general dysarthria severity, about their general neurological state based on the movement analysis. And the core idea is to show the daily progress, how the patients perform like within the set of 5 or 6 exercises that the patient perform every day. How we track the progress on time of the results. And like every day we show this screen to the patients. So, okay, today you have 77% level the results you have in terms of speech, tapping, and movement. And then within the different days that the patient perform the different exercises, we track like the progression of the performance of the patient when they do the different exercises. Now, what about this is what we have now, but how this can be improved, how to continue this work. There is a set of additional exercises to evaluate other symptoms that affect the patients. For instance, we already start to collect data from facial expression in Apkinson in order to evaluate hypomimia events. Apkinson, another idea is to incorporate into Apkinson other tasks like image description and retelling stories to evaluate as well cognitive symptoms in the patients, or that can be adapted as well to other diseases like Alzheimer's or dementia. Also, another exercise that can be incorporated into Apkinson is, in order to evaluate handwriting, is to use the camera to take pictures of the handwriting exercises of the patients, to make the patient to draw a spiral or to write some letters, and then to take a picture of the the sheet, or do it online as well within the smartphone. Another point that has to be addressed is the exercise gamification in order to make the app more fun for the patients, in order to motivate them in a better way to use the app like every day. So example of games that can be include trivia games, or these games that where a character is moved within left or right or up and down, like avoiding obstacles, among other games that can be included in the app. Also, it is important to improve the continuous monitoring aspects within the app in order to track as well, for instance, the medication intake of the patients when the patients perform the exercises. Also incorporate the push notification to remind the patients to take the medication within, according to the prescription of the neurologist. Also to track the disease progression of the patient and to communicate this to the hospital or to their expert neurologist, in order to the clinical expert to check the results of the patient, and just in case, just to update the medication of the patient. An important aspect as well to consider is, in order to improve the quality of the app, is to make them social. For instance, it would be good if patients can share their achievements with their contacts. These aspects also motivate the patients to use the app in a continuous way, or the assessment of group exercises that two patients have to do together in order to achieve a common goal, and also the development of a reward system as well. Everything is the objective of all of this is to motivate the patient to keep using the app. Also, another important aspect is the one related to data privacy. Clinical data is very private, and very important to keep within the smartphone, which cannot be like transmitted to a server to be analyzed. So it's important to consider as well different algorithms to process the data within the phone. And how can we do that? With the use of federated learning strategies, some federated learning algorithms that helps to train the system on the edge and over the phone, thus the data cannot be transmitted to a server. And also the metadata anonymization in order to keep the patient's data to themselves. Also, this is just a first use case of an app for the assessment of pathological speech. This can be adapted to other populations like children with cleft lip and palate, patients with depressions, patients with hearing impairments, and in general, for patients that have to do some rehabilitation after a stroke, among others. The ultimate goal, as I mentioned, is to improve the quality of life of patients and to make the patients move, to make the patients active. It is better to, if they do some exercises every day instead of being at home, so this is everything according to our Apkinson experience. Again, thanks again to the TAPAS project, to validate this study. And thank you all for your attention. I'll keep the microphone open for comments and questions.
Okay. Okay, thank you, Juan Camilo. You can hear me? I
Yes,
hope so.
Gwen,
Yes.
Yes, Gwen, I can hear you.
Congratulations with Apkinson. It's, I think, a very attractive app. And are there any questions here in the, yes? Wait a
Hello.
moment, Juan Camilo.
Thank you very much.
Oh,
yeah.
Okay, yes, then Diana.
Yeah,
Please ask your
thank
question.
You. Thank you, Camilo. The application is amazing. This is something such a very good work. Thank you for presenting this. I have seen I watched the video you have in YouTube. It's also very good video. Yeah. I would like to listen about your experience a bit on using this with patients, how you are testing this with patients currently.
Yeah, patients. I mean, nowadays, everyone use a smartphone like normal. I mean, it's not like a couple of years ago when especially elder people were so afraid of using those type of technology. But right now they are very open. They are very happy that this tool exists and they practice a lot. In general, they use it in a normal way. I mean, yeah, like WhatsApp, like any games. So I think that the core idea right now is just to make the app like more fun for them in order to keep them motivated to use it. But with the current version, the patterns of use, I mean, they are very open and they're very happy that the app is made for them.
Yeah, and about numbers, how many patients have tested this?
Yeah.
You have some feedback about
Yeah,
the
yeah.
hospital, how many hospitals, your plans on how to look
Yeah.
forward on this?
Yeah, right now the app was tested with 20 patients in Medellin, Colombia. Yeah, we collect data from them, the speech and movement data from them. Again, the feedback from them was very positive. They continue using the app. They have installed the app. They keep going using the app. And regarding the use in the clinic, yeah, we are working right now on that. I mean, right now some clinicians are using the app. I mean, we still miss the communication between the app and the clinical center. Right now, it's only to the patient to make the exercises every day and to make them, yeah, to practice at home. Then when they go to the clinic, they can show some results to the doctor.
And can we use it, for instance? I mean,
Yeah.
if we want to
Yeah, the app is in the Play Store as well.
Cool.
Yeah, the app is in the Play Store and the source code is also available online.
Yeah, okay, nice. I'm going to try it, sure. Thank you very much again.
Yeah.
Thank you. Any other questions? Wait a moment, Juan Camilo.
Hi, thank you for your presentation. I was just wondering, so you were saying that so your plans are now to make it a bit more fun, and I was just wondering if there would not be a line that you don't want to cross, because we're still talking about patients that have a neurodegenerative disease. So the whole system with rewards and stuff like that, I'm not talking about experience, but I'm wondering if that might not have an emotional impact on the patient when they start seeing that they can't get the rewards anymore, actually. So I wonder if so I think you need to have a good, right middle between fun and still kind of neutral, not to demotivate the patient.
Yes, you are totally right. Yeah, there is a line, yeah, of course, to crosses in order to, the app shouldn't be competitive for them. I mean, there's not a competition for the patient. The core idea is to motivate them. I mean, that's why we always gave them positive feedback. It's like, you are doing great today. Keep practicing your exercises. Or, I mean, the reward system, it's more like, hey, you did 2 exercises today. Or, hey, you did 3 exercises today. Or, hey, you have a record of 10 exercises within a week. It's more like this type of rewards rather than, hey, your pitch is stable. Yeah, it's more like the rewards will be more like keep practicing or keep using the app rather than hey, we just do it great, or or you don't do it that much great. Yeah, there is this line that we have to keep.
Okay, Juan Camilo, would it be possible that the clinician set the goals for patient?
Yes, that would be a really good idea to implement. Yes.
Okay, and do you have any idea about the adherence for home practice with the app? Because I can imagine that it's not easy for the patient to think all the time about the app and to actually practice.
Yeah, probably not every day. I mean, we use like push notification to remind the patient every day to do the exercises, but yeah, there should be combined with some additional information to guarantee the adherence of the patient. We have somehow to make some plans to measure that.
Okay, there is a question on the chat, and thank you very much. Can you explain the federated learning strategies used for data privacy a little bit more?
Yes, there's a federated learning. I mean, in general machine learning, the models are trained in a centralized manner. We collect a lot of data that are trained on a server, and then we learn some insight and some information. So the aim is to predict or to classify something. In the case of federated learning, the training is distributed across multiple devices. In this case, across multiple smartphones. And the general idea is that for this case, the data is not transmitted to a central server, but the flow of the information. And for instance, when you train a neural network in a federated learning approach, what is transmitted to the server is not the training data, but the flows of the gradient, which are used to update the model within a server, thus keeping data privacy secure in the patient's home, in the patient's smartphone.
Okay, another urgent question is.
Emilio, thanks for the presentation. I have one question, like how easy is it or difficult to change the backend here? You know, like if you want to put a new algorithm or you want to change maybe the way you want to evaluate, you know, the patient, PD patient. So how easy or difficult is it to do that with this app?
Yeah, the app was built in a very modular way. So every algorithm, every processing method is in a different class within the code. In addition, as we have a exercise manager system, it is also very straightforward to include new exercises as well. I mean, probably if we can include an exercise to track retelling stories in patients with dementia, or yeah, that's also very straightforward to implement.
So one question that emerges also is that, do you have any advice, like when people want to integrate their method or something to evaluate the PD patient symptoms? Do you have any advice, like when should we do or how should we do kind of with this application? You know, we don't want to give an app to the patients, and then if it doesn't work, your methods are not working well. So how like what level you should decide to integrate into this app? Do you have any idea, any suggestions on that?
Yeah.
You know, like there are many things, right? So we do initial studies and we develop on some other databases and everything, and then we, you know, come with some performance measures and so on. But in the end, when it goes into the app, you know, there is always this question that at what level one should be bringing in before they start integrating into the app. Should they just integrate and then improve it, or you know, try something before, test a few things before and then integrate? What would be your advice on that?
Yeah, there are two different things that should be tested in advance. The first one is to evaluate the method and the model in terms of the acoustic conditions. I mean, it's not the same to evaluate the model within speech data collected in a very controlled conditions. I mean, compared with the clinical setting or the acoustic settings that are available in a smartphone in terms of the acoustic conditions. So that should be tested initially first. And the other thing that should be considered as well is the speed and I mean the computational complexity of the system. I mean, it's not the same to have a metric or a model to run within a desktop computer or within a server, which is very complex, and compared with the computational capacities of a smartphone to process the same metric. For instance, a model that runs in a couple of milliseconds within a server, it will take a couple of seconds or minutes to run off a smartphone, draining completely the battery of the system. So these aspects should be considered as well in advance.
Thank you.
Okay, oh, sorry, thank you. Okay, I think we better continue with the next presentation. So thank you, Juan Camilo, for this wonderful presentation and all your answers to our questions.
Yeah, thank you, Gwen, and thank you, everybody.